Elouise and I'm part of the maths team here at the University of Wolverhampton, and this video is on writing and balancing chemical equations. So when you have chemical equations, we need to make sure that you have the same number of each type of atom on both sides of the equation. So as you can see here, we have calcium on the one side and we have calcium on the other, and there's just one of each. Now, you need to make sure that it's just the atoms you're balancing. So because there's hydrochloric acid on one side doesn't mean that there needs to be hydrochloric acid on the other side. It just means that you need the same amount of hydrogen and chlorine on the left as hydrogen and chlorine on the right. So to balance equations, there are some things we need to know. If there's the little number in the bottom right after an element, it means there's that many of that element alone. So in H2O, that means 2 hydrogens and an oxygen. In CH4, it's 1 carbon and 4 hydrogens. If there's a number in front of a molecular formula, you multiply all the atoms by that number. So hydrochloric acid is 1 hydrogen and 1 chlorine. 2 HCl is 2 hydrogens and 2 chlorines. Now, things can get a little bit complicated when you combine this along with the last one, say H2O. If you have H2O, that's 2 hydrogens and 1 oxygen. But if you have 2 H2O, you end up having 4 hydrogens because you have 2 lots of the 2 hydrogens. And don't forget, you also have 2 of the oxygens. So the main places where you can maybe trip up in this is forgetting to multiply all of it. For example, forgetting that there's 2 hydrogens to multiply by 2, or forgetting to multiply another one of the elements. So you've multiplied your 2 hydrogens by 2, but then you forget to multiply your oxygens by 2. This is why I've drawn it out in this example. I found that this really helped me when I started out balancing chemical equations. Obviously, if you have a really long chemical equation, it's going to take a lot of time to do this. But while you're practicing, it might be a good idea to help you along. So, balancing equations. The steps that we do are we write the word equation, and then from that we write the symbol equation, and then we check if it's balanced, and then we adjust. And we keep doing that until we find out that it is balanced. So just because you've adjusted it once, it doesn't mean that it's fully balanced. You adjusting it may have made something else imbalanced. So we keep checking and we keep adjusting until everything is balanced. So let's have a look at this one. If we had magnesium and hydrochloric acid, which makes magnesium chloride and hydrogen, we'll write out the chemical equation. So Mg plus HCl makes MgCl2 plus H2. Now, if you don't want to do the option of drawing it out, an easier way to do it is by having a table. So magnesium on the left-hand side, there's 1, and there's 1 on the right-hand side. Hydrogens, there's 1 on the left-hand side and 2 on the right, and chlorine, there's 1 on the left and 2 on the right. So the left-hand side, which is what I mean by LHS and RHS is right-hand side, needs 1 more chlorine and 1 more hydrogen. Well, the really handy thing is on the left-hand side, there's an HCl. So if we have 2 HCl, we're getting an extra hydrogen and an extra chlorine at the same time. So we do that, 2 HCl. And then again, we need to go through and check to make sure that it's still all balanced. And we do check and it is balanced. So that's fantastic for this one. Another thing that you need to keep in mind is when you have ionic equations, you also need to make sure that the charge is the same on both sides, alongside making sure that all of the elements balance. So it's an extra thing to make sure it's balancing. So let's take this. For example, you have sodium and a hydrogen ion, and that makes a sodium ion and hydrogen. So let's have a look. Well, we have 1 sodium on both sides, but we have 2 hydrogens on the right-hand side and 1 on the left. The charge is balanced, but the hydrogens don't balance, so we need to have an extra hydrogen on the left-hand side. So we make 2H+. But now that's made the charge imbalanced because there's a charge of +2 on one side, but on the right-hand side it's +1. So we need to add another sodium on the right hand side to get another positive charge on that side. But of course that then throws out the balance of the sodium, so we need another sodium on the left hand side. Okay, so we end up with this equation and we check it and it's balanced. So this is why it's really important to make sure that once you've made one adjustment, you do keep checking. As you can see there were lots of different adjustments that we need to make. And that's it for this video on chemical equations. Hopefully you found it interesting and hopefully it helped you. And don't forget to check out the other videos that we have in this section.